All right. Well, hopefully you had a nice break. Maybe you got to relax a little bit and revitalize. Maybe you got to catch up on some work. Um, but we now are in the final stretch here. I always think of when I used to run track and field um, and run the 400. You do one loop around the track, and it's just you go around the track, right, and then you hit this final curve, and you just round the final curve, and it's just a straight shot to the finish line. But you're really tired, you're exhausted, and you're just trying to keep going for this final stretch. And I always think that's what this after Thanksgiving seems like. We've got 2 weeks left, and then finals. And we got lots of stuff. There's lots of stuff to do in that time. You're going to probably be overwhelmed by projects and exams and all that in your classes. So we'll try to see how we do with this class. And I'll just warn you, we tend to overwhelm you in this class too, but I think it's manageable. And we've laid a lot of it out so that you can work. We'll spend time this week and next week working on these final projects and stuff like that. So I've opened up the rest of the course here, so you can everything that we're going to do in the course is now available for this. So we've got. Let me go to. This is better. So we're going to be doing Unit 14 this week on testing and debugging there. So again, not necessarily new programming concepts, but a new concepts as far as almost like software engineering. How do you test what we call unit tests on your software and what they are, and what are some debugging strategies there. Next week, we'll spend most of the week reviewing. There are two things coming up, and working on the final project, I guess, is next week. There's two big things coming up. The final exam, which is finals week. The exam will be December 17th at 8 a.m. Here in this classroom. So you'll come here at 8 o'clock in the morning and take the final exam bright and early on that day. That is the time we're given, we're assigned. I did not choose that time. So and it rotates every semester. We get a different time somewhat. So what we'll be doing that, and we'll be preparing that, and we'll talk about some extra credit review problems for that. The other thing is the final project here. We've divided this into, I think, 5 steps here. Let me bring up the final project description here. So again, in the final project, you're going to make a Java program. It has a set of requirements that you have. They're not the same requirements. I guess it's a menu of things to choose from. You have to choose 25 points of options from that list there. So that should allow you enough flexibility to do any type of program you want. I'll just warn you, and we'll talk more about this later in the week. Students tend to try to do more complicated things than they should. I mean, you are just Java 1 students. What you can do is somewhat limited there. So keep that in mind. And we'll talk about that in the next couple, this week and next. Here. I think Friday this week is spent on the final project. And again, the final project is broken up into these steps here. The first one is a design document describing what you're going to do and how you're going to do it. And then the second step is a prototype, just a beginning version of your program. It's not functional there, but maybe has part of the user interface and stuff. Those two are due this Sunday on December 7th. And then the following Sunday is the final app is due. And then we will demonstrate it at the CIS showcase. You may not have been to a CIS showcase yet. So every semester we have a big gathering of all the computing students. It's always the Monday of final exam week. And it's always in this lab and this other lab. And everyone sits at their computer, brings up their final projects, and shows them, and everyone else wanders around and looks at them. And we usually, there's some structure to it so that you don't have to be at your computer showing your project the whole time. You'll show your project for like half the time, and you'll wander around and see other people's projects about half the time there. And so you're demonstrating it a lot to other students, other faculty, things like that. I'll certainly be there to look at your project there. And then we have pizza and snacks to eat while we're doing this. So it's kind of a celebration of your projects in the class for that. If you can't make it to that time, talk to me and we will look at an alternative for that stuff. And then you write a retrospective of your project that's due before you leave for break. So, but again, a lot of this 2 big steps are due this Sunday. So we don't really have any assignments this week. So if we go into this week's stuff, we look through this. We'll be doing unit testing, and we'll do an activity on unit testing here. And for the discussions, you'll post your work. So on Wednesday, we'll do this red-green refactor POGL activity, and you'll post that to the discussion area on Wednesday in class. Again, the assignments are to work on your design document and your prototype for this. There's no other assignments this week for this. That makes sense? Okay, so let's jump into unit testing. And personally, there's really not, unit testing is not covered that well in either of the 3 programming material or textbooks that we have. Those textbooks tend to focus just on the language and the programming and not the bigger structure of how we write programs here. But if you go and do any programming in the real world, you're going to have to do unit testing here. There's a whole area of testing, software testing, one that's out there, and unit testing is just one part, is the first part of that stuff. And the idea is that when you work on a program, you often are adding maybe a class or some code, and then maybe it's just a procedure that you're modifying or adding. And then when you will make changes to it, you want to test it to make sure your changes work there. These programs are big and complicated, so you can't like test the whole thing. Well, you can. There's things called system testing where we test the whole system. But before we even get there, we want to test individual parts of this. And you may have seen this already, where you might be writing a program and there's some part of it you want to test that's in the middle of it, and you have to run the whole program just to test your one little thing. And you want to test it in a lot of different ways. You might have to run your whole program, a dozen times to get each time to just get this one little section. So there are ways where we can write tests that will just test that one section without running the whole program here. So because we don't have that, last year I used AI to bring up some descriptions of unit tests, and I left these in. These are okay. You can also just ask AI now to talk about, here's the prompt. So you could just, if you want, interested, you could look at the newest version of ChatGPT or um, Claude or Gemini or whatever and see. But again, they're slightly different, better models now, so they probably will have maybe slightly better answers. But again, this is pretty straightforward explanation. This is not complicated thinking, thing. And there's lots of stuff. So like here, talks about this sort of process here and what test is. Right now, this is talking, ChatGPT now talks about arrange, act, and assert, and we will cover that in just a sec. And it gives a sample quiz, unit test, which is good. So, but let's just talk. So unit tests, we're going to test small isolated units there. We're going to set it up so that they run automatically. The idea is that as you write code, you add unit tests to your code to test out different functionalities. And then as you make more changes, you can just run all your unit tests and you can see if you broke anything else in your code for, that when you're making these changes. So we have an automated test environment and we use these assertions. We'll see those in just a sec for this. Most software development positions, when you write code, you will have to do unit tests, write unit tests for your code and have your unit tests pass before you bring your code back into the main branch, what we call. Typically in coding, we use something called Git for source control to control, this. And so what you'll do is you'll take, like at the start of a week or what we call a sprint, you'll take the code base and you'll create a branch off of it, a copy off of it, and you'll edit that branch. And then at the end of the week or the end of the sprint, you will push that branch back up, merge that branch up with the main code. But while you're working on it and you're putting in error, updates, you might break the code, but it won't affect the main branch. It'll just affect your sub branch that you're working on. And so then when you want to merge that branch in, you'll have to do unit tests and pass unit tests and show your supervisor or your sprint leader or whatever, that, here's a past unit test, and then they'll merge your code changes in with the main branch. And this is usually run like on a 2-week cycle. Every 2 weeks, you'll create a branch, do edits for whatever you've been assigned, and merge those in at the end of 2 weeks. Again, it's a real common process for this stuff. So, another thing we often do with this coding is what is called refactoring. We've talked about, I think, refactor a couple of times. That is where we'll take code, we won't change its functionality, we'll just better organize it. There's a concept what's called technical debt. Sometimes we do things quick and dirty when we're first getting things to work, and they're not the best for long-term maintainability. And so later on, we'll go in and we'll refactor, we'll clean up the code so that it's better and more maintainable. And if you have unit tests, you can refactor and show that you didn't break anything. You reorganized it and everything still works because all the unit tests still pass. I was talking to someone, I think he works at I think it was Matt at Target, and they were saying they try to have 75% coverage of their code with unit tests. So they'd like, in a perfect world, every method has every procedure has unit tests, and that never actually happens. But they try to shoot for 75% of all the things are covered in, 3/4 of the stuff is covered with unit tests. So, okay, how do we get started? We're going to choose a framework and set this up. So before we do this, let's just talk. I'll just warn you, I really don't like doing testing. It's one of those things that I just don't like. Some people really like to do tests and run tests. I know, one of our alumni, Mike Floor, works at one of the gaming place. I think he works at Epic Games there and as a tester. doing this sort of software unit testing at Epic. And, you know, he just loves it. It would just drive me crazy do this sort of stuff. So, but there are whole careers for as a tester, and you can bring them up on LinkedIn here. So why don't you take a minute and go to some job search place, go to LinkedIn, just go to Google and search for, software testing jobs. If you and tell me give me some titles of what we are. What is a software tester commonly called for this stuff? And I'm gonna look. Let's do in Minneapolis. Oh, Minneapolis is so boring. Let's do. My daughter was just in Denver. Let's look in Denver. I like Denver. Oops, I lost my. There. Okay, I just want some job titles out there. If you know approximate salary range, that's fine also. That'd be good to see. So we need 3 before we can move on. So my office is just down the hallway from the music rooms, and I get to hear the steel band practice a lot, the steel drums, which are really good when, like, about this time of year. But the first couple of weeks, it's a little hard because they're just learning that. But then I come down in this room and we hear the radiator this time of year, and just if it were a consistent beat, it'd be better, but that radiator just drives me crazy in this room. So, okay, give me job titles as software testers. Senior quality engineer. Okay, that's one. Quality control analyst. Okay, and someone else. Quality assurance tester. Yes. And I searched for quality software tester, but most of yours talk about had quality in the title, and that's often the key term if you're going to do it. And quality analyst or quality engineer, those are 2 common terms for a software tester. There is something like that. So if you're looking for jobs or internships or work on that, you do it. And it's often abbreviated QA here. So you often see it's a QA engineer or QA person or QA position there. And that usually means it's in software testing. So here we have a QA tester, another QA tester, QA engineer. So you see that a lot for these positions. And some people really like those, and they're really nice positions that are out there for that. So, okay. Let's talk about Java, because so each environment is going to have slightly different unit test environments. And in Java, we generally use something called JUnit testing framework. Excuse me, and at least when we're beginning. And so that's what we're going to look at is this JUnit test here. So in order to get these things, we'll have to annotate our code. And I don't think we've looked too much at annotations. They're like halfway between a comment and a code. So, comments are like slash slash stuff, and the computer ignores those. And so those aren't really code. Annotations are kind of are at in Java, they're at sign lines, and they tell the compiler what to do or some information. So they are handled by the computer, but they're not part of the programming language. They're almost like meta language sort of stuff. So they tell the computer about the code that's coming up there. And so you'll see we'll have to put before a procedure that does a test, we'll have to put an at test there. There are other common annotations that we put in there. Another thing is we do assertions. This is a new programming, I guess, statement that we'll use that is basically just used for testing, where we'll say test this and we'll say assert for our tests. And we'll look at those in just more detail just below here. So, okay. So here's some examples of tests here. And again, you'll see the at test at start. So again, often we were making our own class just for testing. And often for each class, and again, we haven't talked too much about classes here. And so this will make more sense if you go on and learn more about, in future courses, we'll create our own classes, and it won't be uncommon for you to have like a Java program with, 5, 10, 20 different classes in it. And for each class, then each class will have its own little function or its own area that it works on, functionality that it kind of contributes. And we often then write a unit test class for each of the classes. We'll have a unit test one. So here we have a class, and then here we have a method. We're going to test addition. We're going to say at test, and then we have a procedure here. We do some calculation. We do something we want to test, and then we check the results. And to check the results, we do an assert. And there'll be different types of asserts here, but we'll do an assert. So I found really interesting last year. I wonder where this example is, because both large language models created this exact same model for their test plan out there. So let's see if it did it. Yeah. And even today, we're still doing that exact same sample test here. Now, you don't have to lay it out in any particular way for this. You can be setting up your test in different ways here, and you need to have an assert. But we will follow this structure that we'll see here, the AAA structure. We'll do an arrangement. We'll set up something we're going to test. We'll do an act where we'll actually call the method or do some action here, and then we'll do the assert. This is where we'll test the result out of our stuff. And so when we look at unit tests, we will structure it this way with an arrange, an act, and assert sort of stuff. Just as it's not the only way, but it's a common way of setting things up for this. So let's go down to this cancer screening example and open this up in NetBeans, because I want you to see how to run unit tests. So download this zip file or this. So again, where are we? We are in Unit 14, the learning material here on unit tests. We're scrolling down, past the LinkedIn stuff, down here to the cancer screening example. And I'm going to grab this one and bring that into NetBeans. I'm going to grab that URL I'm going to go to team. I got to click on a project I was like, wait for this to get set up here. Okay. There, git clone, paste that in. So this is a sample solution to one of the practice problems back from Unit 5, cancer detection. The idea is that we have um, we're trying to detect breast cancer, and we have a couple measurements, the tumor radius and the tumor concavity there. And then depending on the radius and the concavity, we're either going to say that that tumor was malignant or benign here. So we have some code for that. And so that's where we're getting the sample code in. So here's our main method. And so we're having some loops here. We want to make sure we don't have some mistakes in entering values. So we want to make sure that when they enter the tumor radius, it's between 0.1 and 25.0 here. And then the concavity has to be between 0.01 and 0.35. So we have this like read radius where we will ask them to enter a tumor radius, read that in, make sure if it's in the range. If it's not, we'll give an error, and we'll keep looping until they enter a radius in that range. And again, same with concavity. We'll read in the concavity, make sure it's in the range. If not, we'll return it there. So I have those. And then we have a classified tumor where we're given the radius and the concavity. And then again, we do our checks for certain things, and then we return either malignant or benign here. So we have a number of methods here, procedures that we can test out, and our main program for that. So now let's look at our tests here. So let's look at where the tests are. So again, we've been ignoring, we've only been looking in the source thing. There are these test packages here. So if you look under test packages, you'll see the cancer screening tests. And these are the different tests that are set up to run. So now how do we run these? Now, normally you just go here and you run the program. So if I do that, if I just run the program, and again, I don't want to run the whole program. I just want to test out the different things. So again, this requires me to enter a tumor radius. And again, if I enter it wrong, I have to enter the right size here. And then concavity. And then it tells me if it's benign or malignant. So that's running the program. So how do I run the unit tests there? So we wanted to choose run and then the test project here. And it should pop up a window of our unit tests and show our test results window here. And let's see if I can. There, and I should be able to, there should be a little triangle here where I can display all the tests and if they passed or not. And in the testing world, red is bad, green is good. red is a stop line, is an error, is a problem. Green is go for this. So we want to be watching for those. Let me see if I can, there. I thought I could make that a little bigger, but I can't, it looks like. So again, I'm running all these tests here that are testing out different things here, and they're all passing for this in my test results pane. So again, usually you'll have a way in your environment to run the tests, and you'll have a special window that'll pop up that'll display the test results here. Yeah, I'm trying to figure out. I don't use NetBeans that much, so I was wondering if there was a way to bring up the tests where here if you can't find the test windows, you can go up to Windows IDE tools and then bring up the test results that way. And it's not uncommon to put those in different spaces, or you can even put them out on a window on your own if you want for this. Okay, let's see. Let's try to make some changes to these tests and see if one fails here. So let's say we had an error in our code for this. So if I go back into my Java code here, and let's say I didn't worry about some values for testing here, I changed. I had something wrong in one of these tests for this. So maybe I had this. I'd forgotten this part of this test in here. So if I'm missing something, now I could run my product test, but now I should be able to just go over here and rerun all my unit tests there. And again, one of them should, it should identify there's an error here. So the idea is that we'd have enough tests. So if there's an error in our program, we'll miss something. And then I can see, oh, wait, this is this failed here. What failed with this error? Expected benign was malignant. And then I can go look. And so you can then go look at your test case and see, this is to test to classify tumor stuff. And let's just look at how this test is set up here and what it tells us. So for the arrange, we initialize some variables, set the radius to a value, set the concavity to a value, set the expected result to a value. For the act, we run our tests. So here's we call classify tumor, we specify the radius and the concavity, and we get the results. So we have our expected results and our actual results. And then we're going to check if these are equals. And so again, rather than doing just like if they are equal, print success, print fail, we do an assert. So in our test, we always do an assert here. So we'll do assert equals, and we'll compare the expected result to the actual results for this. So again, here we're just testing this when these two values are radius is 0.1, concavity is 0.01. It should be benign, but it wasn't. So there's some error with that. And then hopefully that points us a spot in our code where we'd go in and fix that error. Oh, we missed that. We put that in and rerun our tests. And now everything's coming up green, hopefully. And again, these are just samples of, a few tests. In reality, if you are writing tests against this, you've got to test probably, for each one of these values, let's just look at. You want to test the radius right around 0.1. You want to just have a little bit below that and then maybe right at that. And again, here you want to do a test. So you probably have 2 tests for the lower bounds, 2 tests for the upper bounds, 2 more tests for the lower bounds, 2 more tests for the upper bounds. So that's 4 tests at minimum just for these methods. And then here, you're probably doing quite a few tests to make sure you're covering all of these ranges here. So you might have, a dozen or 20 tests of different combination of these values to try to get at this. And we often are looking at testing at certain critical values here for this. Okay, let's go back here. Let's talk about this assert statement. So again, this is new. I kind of lied at the beginning of the class. I said we weren't going to do anything new in programming. So this is one new statement. But again, it's only in the test world there. And it's actually a whole bunch of statements here. You can assert if 2 things are equal here. You can assert if something is true. So sometimes we'll have a Boolean condition there that'll be true, false. So you can assert that it should be true or should be false. You can assert that some value is null or not null. We haven't talked too much about null values. It gets more important when we get on to object-oriented programming here. You can, so equal, see just like if 2 strings are equal to each other. Assert same means we're pointing to the same area in memory, so it's a slightly different thing. Here you can assert if 2 arrays are equal to each other for this stuff. So again, these are common assert methods in Java. In other languages you'll have, and other testing frameworks, you'll have different assert statements, but similar to these sort of stuff for this. Let's just talk, we mentioned before, range, act, assert. That's our pattern that we'll use for defining tests here. So we'll always do this AAA common, we'll do it. And again, so this is an example. All these tests will have an arrange, an act, and an assert structure for these. An arrange, an act, and an assert structure. So now one thing's interesting here. I don't know if I mentioned it with equals. So assert equals is fine if you're comparing 2 strings. If we're comparing 2 decimal numbers, they could be very, because of rounding errors, they put to be nearly identical, so one could be like 3 and one could be 2.9999999. So they're really equal, but just because of rounding errors or some math stuff, they're not exactly equal. So when we do assert equals, we can specify an accuracy. Are they equal within, 7 decimal places or something like that? And that's sometimes what we'll see happen, is that sort of checks for this. Okay, so arrange, act, assert sort of process is what we'll see a lot with unit testing with these. So why don't you try to look at these tests and come up with a new example of one of these tests for this stuff. Try to create your own test. Try to read through these tests and pick one of them that you want to try here. So there are different tests. One is test this classify tumor method. Another one is when we're putting some input here. Oh, and I forgot to mention, how do we test when the user does input? So for those, we are actually creating our own input, keyboard input, and we're creating a simulated keyboard, a special type of scanner for that. And then we are calling our method with our simulated scan keyboard here. So, and are you familiar with the slash n? Backslash n means a new line there. So what this is doing is saying you enter 30 and then hit enter or a new line, and you hit 24 and hit enter there. So that's just like here for running our program here. And I'd enter 30, enter 24, enter. And again, if I do that, it should read in the radius correctly. One mistake, and then it should work correctly. So see if you can modify these unit tests and add one of your own unit tests that should work here. Okay, let's see what you did. So did you make a example? So again, there are different types of tests here. One I was looking at is this, we test some invalid radiuses when we enter the radius. Here we test if it's too low or too high here. And I thought, I wanted to do one right at this high point at 25.0 there. So if they enter 25.1, it should reject it. If they enter 25.0, that should be acceptable. It's that number between. So I'm thinking that's inclusive. So I made a test. I copied this test and make a new test where I tried 25.1 and then I hit enter and it should reject that. And then I tried 25.0 and entered that and it should accept that. And so then I changed the expected result. Should be not 25.1, but 25.0 here for this. And then I check the results. So again, and then naming these, we want often to have the test results to be useful here, so that often when we see the name, it kind of gives us an indication of what might be going wrong with that. So, but it's hard. So we have two different. I mean, we're just testing invalid radius being too high. So I just called it high too. That's not a very descriptive name, but best I could come up with. Similarly, when you're trying to test like this malignant or the classification, I'd like to test right around these bounds here. So you may want to, we have some tests here, but I'm going to try and make copies of these tests and do some new ones right at these ranges. So again, when is it malignant? So if the concavity is 0.09, so maybe I make this 0.09, that should be malignant, and the radius is 14.5 or higher. So maybe I make that just 14.6. Then the results should be malignant here. So again, a lot of this is, I can just copy these tests and change the value. So I'm testing that right at this range being malignant. What if I test that same range but be benign? So like if it's 14.4, that should be okay. So if the radius is 14.4 and the concavity, it needs both of those. So even if the concavity is too high, is 0.1, it should still be benign. So again, you've got to kind of understand the problem you're testing out when you're writing these test cases so you can try to adapt them. And once we get those set up, we can rerun our tests and see if they should. If right now, since I think the software works, I should get all my tests passing still for this. Okay, on Wednesday, we'll do more with this. We'll do this red-green refactor progal activity here. I want to get you thinking in our last 10 minutes, 15 minutes here about the final project. So why don't you spend 10 minutes thinking about the final project? So go into the final project description, look at what you might, what the requirements are, and think of some possible project. There's a whole list of project ideas here. So some of these are, so we can do simple games. When I mean simple games, like games that involve rolling dice, games that involve words or text. not simple like pinball or and card games tend to be hard. Working with a deck of cards at this point, it's possible very hard for you to do this stuff. So some games, some simple calculations here, calculate simple math stuff like, return on, like if you invest something or you have a student loan at this much interest, what, you can print out how much you'll have to pay in your student loan, or, calculate the tip for when you go to a restaurant, or golf scores or bowling scores, something like that here. Keeping notes on things, sometimes just a GPA calculator, some ideas like that. So think about what you might want to do for this. Maybe it's something related to a hobby or an interest you have that you'd want to do some calculation or some program with. So start thinking about making a list, maybe even open up AI and talk to AI about stuff. But again, it's got to be text-based. When we run this, it's going to run in a text window over here for this stuff. And one of the problems is if you pick too complicated of a program, and then you use AI is going to introduce a lot of things that we haven't covered in this class. So one of the key goals is to keep this. You can use AI to assist you in parts of this, but again, you've got to keep it to stuff that you understand in this course that you understand. And part of your reflections on this project will be reflecting on making sure you understand all the code that's in your project. So if you use AI to fix an error or do something, make sure you understand what that fix does for things. Okay, so think of ideas of what you might do. So after you spend the last few minutes of class reading through that, brainstorming on some ideas of projects. And Friday, we'll spend most of the day in class working on this and working on your design document for this. So, okay.